So you sent me some notes on something called Battle, right? A new development in LLMs. And the thing that stood out to me, it was the goal of true global language coverage, in AI. It seems like a big step, especially when you kind of look at the current state of open source multilingual LLMs.
Yeah, I think that's a fair assessment. I mean, the existing open source models, they've made progress, but they often have this tendency to lean towards languages that are well resourced.
Oh, yeah.
So just think about like models tend to perform best on languages where we've got tons of data for training, right? Like French, Arabic, German, that kind of stuff.
Yeah, exactly. And like you were saying, that leaves this huge gap. So many people speak languages that don't get the same level of support, like Hindi, Bengali, Urdu. Those are massive populations, sometimes even bigger than the languages we just mentioned. So when a project like Babel comes along and they're tackling this imbalance, it feels pretty important.
Exactly. And the paper really emphasizes that. The goal of Babel is to support over 90% of the world's population. And they're doing that by focusing on the top 25 languages by speaker count.
Wow, 90%. That's almost everyone on the planet. And when you look at the actual languages they list in Table 1, it shows you how serious they are about this. Sure, you see some familiar ones, but then there's Hindi, Bengali, Urdu, even Swahili right there in the mix. You don't always see them in the discussions about the cutting edge of multilingual AI.
And it's not just about the number of languages, it's the sheer scale, the number of people. I mean, we're talking about potentially impacting like 7 billion people by providing solid support for those top 25 languages. That's a huge leap in terms of AI's reach.
That reminds me of that Tower of Babel story, the one the researchers mentioned in the paper. It's like this age-old human desire, to understand each other across all these different languages.
It's a cool way to think about it. Babel, it's like a modern attempt to bridge that gap, but using AI this time. And that sets the stage for some really interesting technical stuff they do.
Okay, so let's get into the how. Like, how do they actually achieve this broader language support? What's the innovation that makes Babel stand out academically?
So the big thing is their approach to scaling up the model. They don't just continue pre-training with more multilingual data, which is pretty common. Instead, they came up with this new technique called layer extension.
Layer extension. Okay, I haven't heard of that. So, what's going on there? Can you kind of break that down?
Sure. So picture your typical LLM. It's built like a stack of processing layers, right? With traditional pre-training, you're basically refining the knowledge within those existing layers. But with layer extension, they're actually adding new layers to that stack. They're literally making the model bigger.
So they're adding these new layers, making it deeper. And where exactly do they put these layers in the existing structure?
Well, the new layers, they're designed to have the same structure as the original ones. And a crucial point here, and they show this in figure 1, is that this expansion doesn't change the core parts of the model, like the attention mechanisms or the embedding layers. Those are key for how the model understands language. They're basically adding processing power without messing with the basic way the model sees language.
Right. Okay, I get it. They're adding capacity, not rewiring the core understanding. So what's the advantage of doing it this way compared to just giving it more data? What's the thinking behind that?
Well, their idea is that this layer extension bumps up the model's potential, its performance ceiling, so to speak. By adding layers, they're giving it more space to learn and represent the patterns in all those languages, even the complex ones. So it could potentially become much better at understanding and working with multiple languages than if they just stuck with the same architecture and threw more data at it.
That makes sense, just in terms of like capacity, giving it more room to grow. Now, the paper mentions they were strategic about where they added these new layers. So where did they end up putting them?
Yeah, so they actually built on some recent research, like the work from Kim, Men, and Zhang. These studies showed that the layers towards the end of these transformer models, they're not as sensitive to changes. So adding new layers in the second half of the model, it's less likely to mess up the knowledge that's already there in those earlier layers.
It's like a safer way to boost the model's power, working on a less sensitive part of the network. And I saw that they experimented with different ways of adding those layers at different starting points, right? What did they learn from that?
Yeah, they tried a bunch of things. They looked at where to put the new layers, whether to mix them in with the existing ones or just stick them on at the end. And they also tested different ways of initializing those new layers, like copying parameters, setting them to 0, adding a bit of randomness.
So a lot of trial and error, huh? What worked best in the end?
Well, they found out, and you can see this in table 2, that just tacking the new layers on at the end, it actually hurt the performance a lot. It seems like integrating them into the existing structure is really important. And for initializing the new layers, just copying the parameters from existing layers was a decent starting point, but they got even better results by adding a tiny bit of noise to those copy parameters. Like really tiny, a mean of 0.0001.
Wow, that's a super small detail. You could see they're really fine-tuning this thing. And did those findings then shape how they set up the layers for their main models, the 9B and the 83B ones?
Absolutely. Table 3 lays out how they did it. For Babel 9b, they basically inserted a new layer after every other existing layer in the second half of the model, starting at layer 14. And with Babel 83b, the bigger one, they follow the same pattern but started at layer 40. It's the same strategy, just adjusted for the different sizes of those base QN 2.5 models they were building on.
So they're showing this layer extension technique. It's not just a one-off thing. It can be applied and scaled to different model sizes. Now, we know a big issue for languages with less data is, well, the lack of good quality data, right? How do they tackle that in Babel?
Yeah, that's a huge point. And the Babel team, they knew that. Data quality, especially for those less resourced languages, it's crucial. So they put a lot of effort into making sure their data was top-notch. They built this really thorough data cleaning pipeline.
So walk us through that. What did they do to make sure their data was good enough?
They had a multi-stage process. First, they did some basic cleaning, getting rid of stuff that was too short and had too many numbers, the basic stuff.
Right, data hygiene, got to keep things tidy. Then what?
Then they did something super interesting. They used an LLM, specifically GPT-4o, as a judge to assess the quality of their data.
Whoa, hold on. They're using an AI to check the quality of data for another AI.
Exactly. And they didn't just rely on the AI's judgment. They had linguists, actual humans, go through and double-check those AI assessments. They even named them in the paper. Tantang Champibun, Nguyen Yen He, Tara Divina Putri. These were native speakers of several of the target languages, so they made sure the AI wasn't missing any cultural nuances or, making mistakes that only a human could catch.
So it's like this cool combo of AI power and human expertise to really ensure that the data is high quality, right? Did they do anything else to process the data?
Oh yeah, they also got rid of duplicates to make sure the model wasn't seeing the same information over and over again. And they pulled their data from a bunch of different places, Wikipedia, of course, but also Cosmopedia, that's a data set of textbooks, then CC News, Culturex, and MadLad 400. This one's known for covering a lot of different languages.
So they really cast a wide net for their data. Okay, so they've got their data cleaned up. Now it's time to train the model, right? The outline mentions this two-stage pre-training process. Why did they do it that way? What's the academic reasoning behind that?
So the two stages are there because of the layer extension. When you add those new layers, it can kind of shake things up. The model might not perform as well as it did before, right after the extension. It needs a little time to adjust.
It's like recalibrating after you've made a major change to the system. So what was the goal of that first stage, the recovery stage?
Exactly. Stage 1, they called it recovery, and it was all about getting the model back up to speed after the extension. So they trained it on this huge, diverse data set with all the languages represented pretty equally. And to speed things up, they included a lot of English data using Red Pajama and Proofpile 2 and Chinese data with YI2. That's because there's just so much data available in those languages, and it helps the model relearn those basic language structures faster.
So stage one, it's about rebuilding that core understanding after the surgery, basically. And then stage two, the continuous training. What's happening there?
Stage 2, it's all about getting that multilingual expertise really sharp, especially for the languages that haven't had as much attention in the past. So they upped the amount of training data from those languages, making sure they got more exposure, and they also increased the amount of textbook data from Cosmopedia in this stage. Their thinking is that textbook data is great for building knowledge that can transfer across languages.
So stage two is about using that solid base they built in stage one to really fine-tune those multilingual skills, particularly in the areas where other models struggle. Now, at the end of the day, it's all about how well it performs, right? How did Babel do in the evaluations?
Oh, they went all out with the evaluations. They tested both the basic models and their fine-tuned chat models on a whole range of benchmarks. They looked at things like factual knowledge, reasoning, understanding, translation. Some of the key ones were MMMLU and M3 exam for world knowledge, XCOPA and MGSM for reasoning, XMLI for understanding, and Flores 200 for translation quality.
So a really comprehensive set of tests. And what were the main takeaways? How did their base models perform?
The results, and they're all laid out in tables 4 and 5, they're really impressive. The smaller model, Babel 9b base, it topped the charts among open source models of similar size. They tested it against Gemma 29b and QN 2.57b, and it consistently outperformed them, especially in those tasks that needs reasoning, understanding, and translation. Their average score across all those benchmarks, it was 63.4.
So not only did it cover more languages, it actually performed better than other models its size. Pretty cool. And what about the bigger model, Babel-83B base?
That one set a new record for open source multilingual LLMs. It beat even larger models like Llama 3.170B and QN 2.572B. I mean, it was consistently at the top with an average score of 73.2 across all the benchmarks.
So it's not just about being inclusive, it's about being at the cutting edge. And did they look at how it performed on individual languages, especially those less resourced ones that were a key part of their goal?
Yeah, they did. Figure 2 breaks it down, showing how Babel 9B base performed on each language compared to its base, QN 2.57B base, and another strong model, Gemma 2 Dice 9B base. They divided the languages into high resource and low resource groups based on how much data was available in the Common Crawl dataset.
And what did they find? Did it actually do better on those less resourced languages?
It absolutely did. Babel 9B base showed significant improvements on the low resource languages, especially when compared to its base models Q1 2.5-7B base. That shows their focus on those less represented languages. It really paid off. And importantly, it did this without sacrificing its performance on the well-resourced languages. It struck a good balance, which is often tricky to do with multilingual models.
That's great to hear. Their techniques are actually closing the gap. Now, they also created these chat versions of the models, right? Can you tell us a bit about how they did that?
So for Babel 9B-Chat and Babel-83B-Chat, they fine-tuned the models on publicly available datasets that focus on following instructions in multiple languages. They mainly use WildChat and Everything Instruct Multilingual, which combined have about 1 million conversation turns in various languages.
And was there anything interesting about using that multilingual data for fine-tuning?
Yeah, they actually compared it to fine-tuning with just English data, and the results are in Table 6. They found that while using only English data helped a bit with following instructions, using that multilingual data led to much better overall performance across tasks and languages. It shows that staying focused on multiple languages throughout the process, even during fine-tuning for conversations, it's really important.
That's a valuable lesson. So how did these chat models stack up against other top instruct models out there?
Well, the chat models also did exceptionally well. The results are in Tables 7 and 8. Babel 9B Chat, it actually achieved state-of-the-art performance among open-source instruct models with around 10 billion parameters. It even beat Gemma 2 9B Instruct, which was a tough competitor. And the big one, Babel 83B Chat, it set a new standard for open LLMs in general. It even performed on par with GPT-4o, the commercial model, on some multilingual tasks, even topping the charts on Xcopa and XNLI.
Wow, so they're going head-to-head with a top commercial model using only publicly available data and their own innovations. That speaks volumes about the quality of their work.
Exactly. And the researchers, they make it a point to say that they only used public data sets. So imagine what they could do with even more diverse and high-quality data, or with even better point-tuning techniques in the future. It's really exciting to see where this could go.
All right, let's wrap this up. For our listeners, what are the key takeaways here? What makes Babel such a significant development?
To put it simply, Babel brings a new and effective way of building more inclusive, multilingual LLMs, and they do it with this layer extension technique, which is a smart way to make the models more powerful. They also focused heavily on data quality, especially for those less resourced languages, and that's a big deal. The result, they've got these models that are performing at the top of their game across a wide range of tests, and that's a huge step towards making AI accessible to everyone, regardless of what language they speak.
It feels like they're really pushing for inclusivity and accessibility in AI, and that's fantastic.
Absolutely. They've chosen to focus on the top 25 most spoken languages, including those that have often been ignored by other open source efforts. It's a big step towards making AI language tech more equitable for a much larger part of the global population.
So as we wrap up this deep dive, I want to leave you with a thought. Think about what we could achieve with truly inclusive multilingual AI. What kind of world would it be if language barriers weren't such a big obstacle in how we interact with technology and with each other on a global scale? And what new innovations, whether it's in the models themselves, the training methods, or the data we use, will be needed to make this vision a reality? It's a rapidly evolving field full of potential, and Babel is definitely raising the bar. Thanks for joining us on this journey.
It's been a pleasure. Thanks for having me.